Hi everyone, my name is Emily Baldout, and today I will be presenting on measles. A little bit of background on measles. Some common names for it include rubella, red measles, 10-day measles, and a common abbreviation includes lowercase e-v. That is one I will be using in this presentation. Measles is a disease caused by a virus. It spreads by airborne and sometimes droplet transmission. It can spread by an infected person sneezing or coughing on a surface, and then somebody else coming by, touching that surface, touching their mouth, and ingesting those particles, or just by airborne transmission. Worldwide, it is a pretty prevalent disease. However, in America, there's only 128 cases. But America is still at risk for infection because a lot of people travel to America and can infect people living here. A little bit about the virus. The virus is a single-stranded virus. It has an envelope. It is a negative RNA virus. The infectious agent's name is morbillivirus hominis. This picture here shows the virus. You can see that it's single-stranded and it has an envelope. So some signs and symptoms for measles include fever, rash, inflamed eyes, a cough, and these things called Koplik's spots. These spots show up, I have a picture here, in your mouth. And they're kind of hard to see, but they're just these little spots that are seen in people with measles. And this picture here is what the rash looks like on the face. Typically the rash tends to appear first on the face and then sort of travels throughout the rest of the body as the infection develops. Here's sort of a timeline of what the disease process looks like in the body. So for the first 10 to 14 days, you don't have any signs or symptoms. You may not even know you have it at all. And then after that incubation period, then you start getting some signs and symptoms. And then a little bit later on, you develop the rash. And eventually, if all goes according to plan, everything eventually will subside and you will get better. So measles tends to enter the body through the respiratory tract or through the eyes. And once it enters the body through these areas, it binds to immune cells via the CD150 receptor. This receptor is present on dendritic cells, T cells, B cells, and I believe macrophages. This picture here shows the virus binding to the CD150 receptor, and then once that occurs, once it binds, the receptor or the virus and the membrane of the cell sort of fuse, and the virus dumps its contents into the cell and infects the cell. And this picture here shows just the particles entering into the eye or entering into the respiratory tract. So once the immune cells have been infected, they travel to other lymphoid tissues, and in other lymphoid tissues, other immune cells are present. And so when these infected immune cells travel to lymphoid tissues, they end up infecting other immune cells. This is a picture here of what that cell-to-cell transmission might look like. You can see this cell is passing on its viral components to this other cell. And here is a picture of those lymphoid tissues and where the infected immune cells may travel to infect other immune cells. And once these immune cells have been infected, they will travel around to the rest of the body and start infecting areas of the rest of the body and areas in the rest of the body. And specifically, they infect the skin. This is sort of when immunosuppression occurs. The individual's immune system is just sort of overrun by this infection, and their numbers start to drop, and their body becomes very susceptible to other diseases and illnesses and pathogens in the environment. And this can be very dangerous for the individual because they're immunosuppressed, so their immune system won't be very good at fighting it at this time, and a lot of other complications can occur because of this. This picture here just shows these infected immune cells entering into an area near the skin, the surface of the skin, via capillaries, and infecting cells around that area. You can see they've even infected the actual epithelial cells and the area around the follicle of the hair. And so immunosuppression from measles infection allows for other infections to occur very easily, and this is really bad. But an infector response will be initiated, and this helps save the body from becoming overrun with infection. And what happens with the effector response is that CD8 positive T cells are released, and these cells work to kill and lyse infected cells in the body. So it's actually kind of interesting because I thought that the rash just came from the body becoming infected, and the body's cells becoming infected with measles. However, the rash actually comes from the CD8 positive T cells working to kill the infected cells. So it sort of causes a lot of that whole process causes a lot of inflammation and also damage to cells, and that's kind of what causes the redness and the rash to appear. And here is a picture of those CD8 positive T cells and that immune response kicking in and working to kill those infected cells. So getting into the transmission and how it's actually spread, infected epithelial cells in the body will actually bud and release the measles particles into the respiratory tract, back into the respiratory tract. And from there, if somebody coughs or sneezes, or sometimes even talks or breathes, those particles get pushed out into the environment. And that's how transmission occurs. You can see here, these epithelial cells are sort of budding and releasing particles, and those particles get pushed up via the mucociliary elevator and get pushed up into the upper respiratory tract. And if somebody coughs, then they get pushed out into the environment. Transmission, like I said earlier, occurs via airborne transmission or droplet transmission. The droplets and particles in the air can survive for up to 2 hours. Measles is a very contagious disease, has sort of like a 90% infection rate. So if you have measles and you're in a room with 10 people, it's very likely that you will end up infecting 9 of those 10 people. Measles also has a very high complication rate because of the immunosuppression it causes, which makes people very susceptible for other diseases or illnesses or pathogens to enter into them and cause problems. So some of those problems that are common include ear infections, diarrhea, pneumonia, encephalitis, and blindness. And some of those, unfortunately, if not treated properly or if not caught quickly enough, can lead to death. There is a vaccine for measles. It is the MMR vaccine. A lot of people get it when they are children. However, there's no treatment for measles after exposure to it. Usually just the symptoms are treated, but you can't really cure measles once you have been exposed to it. You just sort of have to wait it out. There is a post-exposure vaccine, however, and you can get this within 72 hours of exposure. Usually a lot of people don't know they've been exposed, so they don't know to get this, but this is, I guess, for people who do know they've been exposed, and it might not necessarily completely wipe away the chances or the likelihood of you actually contracting such having the signs and symptoms of measles, but it will make them less severe. And then there is an immune serum globulin, and this is for people with weak immune systems that have been exposed, and you can get this within 6 days of exposure. These are my sources, and thank you so much for listening. I hope you learned something.